Hello, my fellow sci-fi lovers, and welcome to Beyond the Known Physics. Let's start with a big question. Is teleportation real? Beam me up, Scotty. We've all heard that classic line. Star Trek painted a future where people could instantly zap from a starship to a planet's surface. It's the ultimate dream, right? No more traffic jams, no more long-haul flights. Just step onto a platform and poof, you're there. But while Star Trek's transporter remains firmly in the realm of science fiction, the core idea behind it is actually being explored by real-world physicists right now. This isn't about moving matter, but about moving information, quantum information. So, that brings us back to our big question. Is teleportation real? Well, the answer is a little more complex and a lot more fascinating than you might think. So, what makes you, you? Is it the atoms you're made of? The carbon, the hydrogen, the oxygen? Not really. Your body replaces almost all its atoms over the years. What truly defines you is the unique arrangement of those atoms, the intricate, complex pattern that forms your memories, your personality, your consciousness. This is your information, your quantum state. Here's a mind-bending rule of the quantum world, the no-cloning theorem. It states that you can't create an exact, perfect copy of a quantum state without destroying the original. So, if we were to teleport you, we couldn't just scan you and print a new you somewhere else. We'd have to destroy the original in the process. This raises a profound question. If your original self is destroyed and a perfect replica appears elsewhere, is that replica still you? When we ask, is teleportation real? We're also asking, is your identity preserved? To understand how this could even work, we need to dive into one of the weirdest concepts in all of physics. Something Einstein famously called spooky action at a distance. It's officially known as quantum entanglement. Imagine you have two particles, let's call them particle A and particle B. When they become entangled, they're linked in a fundamental way. No matter how far apart they are, whether they are in the same room or on opposite sides of the galaxy, they remain connected. If you measure a property of particle A, you instantly know the corresponding property of particle B. It's like having a pair of magic coins. If you flip one and it lands on heads, you know the other one, miles away, will instantly land on tails, every single time. This instantaneous connection is the key. It's the wire through which we could send the information needed for teleportation. So, is teleportation real? Only if this spooky connection is real, and physicists have proven time and time again that it is. And guess what? It's not just theory anymore. It's happening right now. Scientists have already successfully teleported the quantum state of a photon, a single particle of light. Back in 1997, researchers first managed to do this over a short distance on a lab bench. It was a monumental achievement. Fast forward to today, and the progress is staggering. In 2017, a team of Chinese scientists teleported a photon from a ground station in Tibet to a satellite orbiting 500 kilometers above the Earth. They used entanglement to transfer the photon's quantum information across that vast distance. Then, in 2020, researchers at Fermilab and Caltech built a 44-kilometer quantum network, teleporting information with over 90% fidelity. These breakthroughs are incredible. We're moving beyond simple particles to more complex systems. The question is no longer, is teleportation real? But how far can we push it? Or can we? So, why are scientists so obsessed with this? It's not just about trying to build a Star Trek transporter. The real, near-term application is the quantum internet. Imagine a new kind of internet that's not just faster, but fundamentally more secure. In our current internet, data is sent as classical bits, ones and zeros. This information can be intercepted, copied, and stolen without the sender or receiver ever knowing. But on a quantum internet, information would be encoded in quantum bits, or qubits. Thanks to the principles we've talked about, like the no-cloning theorem, any attempt to eavesdrop on a quantum communication would instantly alter it, alerting the users that their connection has been compromised. It would be unhackable. This would revolutionize everything from finance and national security to healthcare and personal privacy. This secure communication network, built on the very principles of quantum teleportation, is the first major goal. Okay? So we can teleport photons. What about a person? This is where we hit the human problem. The human body contains an astronomical number of atoms. We're talking about 7 octillion atoms. That's a 7 followed by 27 zeros. To teleport a person, you would need to scan the exact quantum state of every single one of those atoms simultaneously. The amount of data involved is almost beyond comprehension. We're talking about something like 10 to the power of 28 bits of information. To put that in perspective, if you tried to transmit that data using today's fastest internet connections, it would take longer than the current age of the universe. And that's just the data transmission part. You'd also need a machine capable of scanning, destroying, and then perfectly reassembling trillions upon trillions of atoms. And this brings us back to that deep, philosophical question. If the you on the platform is destroyed, is the you that appears at the destination truly the same person? Or is it just a perfect copy, a clone with all your memories, while the original, you simply ceased to exist? Would you be willing to step into that machine? So, where do we go from here? The next steps in quantum teleportation are focused on building and scaling up those quantum networks. The goal is to create quantum repeaters. These would be devices placed along the network that can receive a fragile quantum signal, purify it, and send it on its way, allowing us to teleport information over continental or even global distances. Scientists are working on teleporting the states of more complex objects, moving from single atoms to molecules. Every step forward, no matter how small, is a leap for quantum science. While beaming a human across the galaxy is still far, far off in the realm of science fiction, the journey of 1,000 miles begins with a single step. And in the world of quantum teleportation, we are well and truly on our way. So, let's circle back to our original question one last time. Is teleportation real? The answer is yes, but probably not in the way you imagined from the movies. We can't teleport matter yet, but we can teleport information, the very blueprint of matter itself, using the bizarre and wonderful laws of quantum mechanics. We're at the very beginning of a new technological revolution, one that could lead to an unhackable quantum internet and perhaps, one distant day, things we can currently only dream of. But what do you think? Would you ever use a transporter if it meant your original self was destroyed? Let me know your thoughts in the comments below. I'd love to hear what you think. Thanks for joining me on this quantum journey. Here at Beyond the Known Physics, we love asking the big questions. Don't forget to like, subscribe, and hit that bell so you don't miss our next dive into the fantastic world of science fiction and science fact. Until next time, stay curious.